Namaskara. Today let's learn about engine speed sensor. From the name itself, we can understand the main objective of this sensor is to measure speed of the engine. Engine speed is not the same as vehicle speed. That is, engine speed is measured at crankshaft level and its unit is RPM, revolutions per minute. Vehicle speed is measured at wheels in kilometers per hour or miles per hour.
12 seconds later.
Now if you observe this diagram, this is engine block, this is cylinder, this shaft you are seeing is crankshaft. At the end of crankshaft, a flywheel is mounted. As I mentioned earlier, here the objective is to measure the engine speed, that is speed at crankshaft. So usually the sensor will be mounted in this region or inside the transmission. If you observe this diagram, here I have taken a gear with only one tooth. That is, this is the reference point for the sensor. That is, it indicates the beginning of the cycle. This is engine speed sensor or ESS, has 3 wires in it. One is positive 12 volts power, second one is reference ground, that is 0 volts, and third one is signal output, usually 5 volts in the form of PWM, that is pulse width modulated signal. The working of this sensor is similar to crankshaft position sensor or camshaft position sensor. If you remember, as soon as this gear tooth comes in front of this sensor, a voltage will be induced. That is, due to the changing magnetic field produced by this gear tooth, a changing electric field is generated inside this sensor which induces an analog signal or AC signal, which will be later converted to digital signal like this. So, every time this gear tooth comes in front of the sensor, a trigger signal is generated. This is first crankshaft rotation, this is second rotation, this is third rotation. That is, ECU will calculate how many such triggers are generated in a minute. That will determine your RPM, revolutions per minute. Instead of this gear, they can use a different type of gear where there are number of teeth and one tooth is missing. That missing tooth will act as a reference point or starting point, similar to the timing rotor of CKP or CMP sensor. Now let's come to the types of ESS, that is Hall effect type, VR type and optosensor or electro-opto sensor. Hall effect type will contain a magnet and Hall effect element inside which generates a voltage when changing magnetic field is detected and it gives out pulse like this. When it comes to VR sensor, that is variable reluctance sensor, which contains a permanent magnet inside and a coil wound around it which generates a voltage when it detects this gear. And when we come to optosensor, this usually uses a laser, that is a laser beam will be continuously illuminated from the sensor and when it detects an obstruction or a gear tooth passes in front of it and obstructing the beam, it generates a trigger signal. Usually this sensor's output is taken as an input to ECM or TCM, engine control module and transmission control module, and from this it will be transmitted to RPM dial or vehicle information panel, and this RPM information can either be in the form of analog dials or digital dials. The first one is in TCM, that is gear shift in TCM. When it comes to AT, that is automatic transmission vehicles, usually the gear shifts, that is either upshift or downshift. That is, when it is upshifting, it usually goes to higher gear from 1 to 2 or 2 to 3 or 3 to 4, and when it is downshift, that is from higher gear to lower gear. Usually the shifting is done using the input of RPM. The upshifts happens at 2500 RPM or 3000 RPM and downshifts happen at a lower RPM of 1500 or when the engine receives a sudden acceleration input from the driver. And in case of manual transmission vehicle, some vehicle gives a suggestion when to upshift and when to downshift in the dashboard, that is usually optimized to maximize the fuel efficiency. This RPM dial has a significant role in motorsports application as well. That is, when it comes to motorsports, we have different categories. It can be circuit racing, drag racing, rally and many others. Each category has its own requirements. That is, let's take F1 racing as an example. Here, each shifts happen in a milliseconds. That is, if a TCM is downshifting or upshifting with a delay of few milliseconds, a driver might lose a position or lose the time, and accurate upshifting and downshifting will help the driver keep his pace. This also applies to drag racing, and usually driver will have a band of LEDs, that is it will indicate a sector of RPM range. That is, if a dial is in yellow, it is at lower RPM, and when the dial is at green, it is at a little higher RPM, and when it turns to blue, it usually indicates it is the time for shifting, and when those LEDs turn red, it is red line limit. This helps the driver to shift gears without looking at the dashboard. The next one is red line limit. At higher RPMs, in passenger cars, it is usually around 6000 or 8000 RPM. Manufacturer programs the ECU in such a way engine speed never exceeds this red line limit. That is, at very high RPMs, engine and its internal will be very hot and are usually stressed, and if we continue to run engine at red line limits, reliability of the engine will come down, parts usually wear out quickly. The next one is launch control. This works with the traction control and usually used in drag racing application. This limits the wheel slip of the car by limiting the RPM during the launch of the car. Now let's understand the symptoms of bad or faulty sensor. That is, when this sensor is giving intermittent signals or bad signals, or it is covered in dust, grimes, grease situations. The first one is improper shifts. That is, TCM will not have an RPM input, that's why it is not able to decide when to shift. The next one is increased fuel consumption. Because of this improper shift, engine will consume more fuel, and we can also observe reduced acceleration in the engine. And the last one is MIL lamp, that is malfunction indication lamp. That is, this is a fault code produced by ECU or TCU indicating some issue in this system. It might lead to situations such as TCU might not allow you to shift gears, or it might go to limp mode, thus limiting the RPM, or it can stall the engine. I hope you understood my explanation. If you found this video to be informative or you learned something, please do like and subscribe to the channel. If you have any doubts or you need clarification on anything, please do comment or DM me in the Instagram. I'll try my best to give an explanation. I'll meet you in the next video. Bye bye.